Hey everyone, welcome. Today, we're going to tackle one of the most powerful and, let's be honest, sometimes confusing tools in SQL, the join. If you've ever had data scattered across different tables and wondered how in the world you're supposed to bring it all together into one meaningful picture, well, you are in exactly the right place. And our guide for this journey? We're going to be leaning on Oracle's own SQL language reference to keep us straight.
Think about it for a second. In pretty much any database that's set up right, your information is split up. You've got your employees over here, your departments over there, maybe sales in a totally different spot. It's organized, sure, but it's in pieces. So the big question, the real puzzle is, how do you combine all that related info to ask the really important questions? And that, right there, is exactly what joins are for.
So here's our game plan for today. First up, we'll nail down what a join even is. Then, we'll get into the real workhorse of SQL, the inner join. After that, we'll explore how to find what's missing using outer joins, touch on a few advanced, kind of specialized tools, and then wrap it all up with a simple guide to help you pick the right join for the job every single time.
All right, let's start at square one. Before we can get fancy, we have to understand what a join really is at its core. This is the magic that actually puts the relational in relational databases. It's how we connect all the dots.
And if we look at the official word from Oracle, they put it really simply. A join is just a query that combines rows from different tables. It's basically you telling the database, hey, see this table and that table? Start putting these puzzle pieces together based on this common link.
Now, before we go any further, a quick but really important warning. What happens if you tell the database to combine two tables, but you forget to tell it how they're related? Well, you unleash something called the Cartesian product. This is where the database just goes wild and pairs every single row from the first table with every single row from the second one.
And let me be super clear here. This is almost always a mistake. If you have a table with 100 employees and another with 10 departments, a Cartesian product doesn't give you 100 useful rows. It gives you 1,000 rows, and 99% of it is just noise. This is the chaos that a proper join condition is built to prevent.
So that brings us to our hero, the most common solution you'll ever use, the inner join. Seriously, this is the join you're going to be reaching for probably 90% of the time. It's all about finding those perfect matches.
And again, the definition here is just super straightforward. An inner join looks at two tables and only brings back the rows where the thing you're joining on actually matches. Seriously, picture a Venn diagram. The inner join, that's just the sweet spot in the middle, that little overlapping part where everything lines up perfectly.
Okay, enough theory. Let's make this real. Here we have a simple table of employees. Notice each one has a department ID. That little number is the magic key, the piece of string that's going to connect this table to our next one.
And here is that next table, our list of departments. We've got the department ID and the actual department name. So our mission is simple. Connect an employee's last name to their department's actual name. And boom, here's what you get. When we do an inner join on that department ID, we get this nice, clean, combined table. Whelan is matched with administration, Higgins and Gitz get accounting. But hey, look closely. See what's not here? The purchasing department. Why? Because no employee in our first table had its ID. An inner join is ruthless. It only gives you the perfect matches. No match, you're out.
But what if you needed to see that purchasing department, right? What if the whole point of your query was to find out which departments have nobody in them? That's where the inner join just can't help you. And it's why we need to pull another tool out of the box, the outer join.
An outer join does everything an inner join does, but with one absolutely crucial trick up its sleeve. It'll also include rows from one of the tables, even when there isn't a match in the other one. And for any of those missing pieces, it just drops in a placeholder called null, which is just a fancy way of saying nothing here.
So outer joins come in a couple of main flavors, left and right. A left join is basically you saying, listen, I want everything from that first table, the left one, no matter what, then just bring over any matches you find from the right table. A right join? You guessed it. It does the exact same thing, but it keeps everything from the right table instead. Which one you choose just depends on which table you can't afford to lose any records from.
All right, let's try this with our data. So if we do a left outer join and we make our departments table the left table, this is the result. We still get Whelan, Higgins, and Gitz all matched up perfectly. But check out that last row. There it is. The purchasing department is back in the picture. And since no employee is assigned to it, the employee columns are just null. We've successfully found the gap in our data.
And just to round things out, there's also a full outer join. Think of this as the show me absolutely everything option. It's basically a left and a right join smashed together. You'll see everybody, employees with no department, departments with no employees, with nulls just filling in all the gaps on both sides.
All right, so we've got the big ones down. Now let's geek out a little and look at a few more advanced joins that are like specialized tools for very specific but very common jobs.
A self-join sounds a little weird, right? Joining a table to itself, but it is incredibly useful. Why would you do this? Well, imagine your employees table has a column called manager_ID, which is of course just another employee ID from the same table. A self-join lets you connect those rows and bam, you can figure out who reports to whom all by making the table talk to itself.
And here are a couple of other really slick, high-performance tools. An antijoin is basically for finding the loners. It answers questions like, show me all the departments that have 0 employees. It's like a super clean not in. A semijoin, on the other hand, is like an existence check. It answers, just tell me which departments have at least 1 employee. And the really cool part is, it won't show you the same department over and over, even if it has 100 employees. It's a super efficient way to see what exists.
Whew! Okay, we have covered a ton of ground. So, how do you keep it all straight? How do you pick the right tool for the job? Let's wrap this up with a quick and dirty reference guide.
Here is your takeaway toolkit. Need the perfect matches and nothing else? Grab your inner join. Want to see everything from one table plus any matches you can find? That's a job for a left or right join. Need to see it all from both sides, no exceptions? Go for the full auto join. Comparing rows inside the same table, like managers and employees? That's a self-join. And for those special cases, if you want to find what's missing, use an anti-join. And if you just need to check if something exists, a semi-join is your best friend.
So at the end of the day, remember this. Joins are not just some dry, technical command. They are your paintbrush. They're how you take all these scattered dots of data and connect them into a single, compelling story. They're how you find real insight. So the only question left is, what story will you unlock?